Hi guys, let's try part 2. Hopefully you had a chance to practice and let me know if you have any questions. Okay, so right now we're going to go to looking and seeing or confirming that we know two functions are inverses. Okay, so we're going to do that both algebraically and graphically. And so let's look at that. So confirming that they are inverses. Okay, so if they ask us to do it graphically, we can use Desmos or your calculator. So look for reflection, okay, over y equals x. Okay, so we'll just go to Desmos and confirm. Okay, algebraically, we will be looking at the composition of functions. Okay, so, and remember that we want those to look like x when we get done. Okay, so let's go ahead and jump right in. So the first one, let's start with a pretty easy one. We have y equals x minus 5 and y equals x plus 5. Okay, now hopefully you're not surprised that these are lines and that an inverse of a line would be a line. Okay, so if you were to fold it, it's going to give you back a line. Okay, so let's go ahead and look at Desmos. And let's go over here. So let's type in y equals x minus 5. And that didn't work. So y equals x minus 5. And y equals x plus 5. Okay. And if you notice, let's go ahead and put y equals x as well. That might help us out. Okay. So this green line here is y equals x. And it does look like my blue line would fold over that line and match the red. Okay. One way I could check, let's go find a random point. So this point is, 6, 1. Okay. So on the blue line, what would a coordinate have to be? It would have to be 1, 6. So do we have a coordinate that is 1, 6? If I go up here, yes, I do. Okay. So that does look like these are inverses. Okay, so that is the graphical way to do it. Now, let's do, so on the graph we check Desmos. Okay, now let's look algebraically. So we'll call this F and this one F negative 1. It doesn't matter which. Okay, but let's do F of F negative 1. Okay. I'm going to highlight at least a couple times maybe to keep us straight. Okay, so let's try this out. So f of negative 1. So remember that means that we're going to put in f negative 1 into the x. Okay, so I start writing f down, and instead of x, I have to put x plus 5, and then I put the negative 5. Okay, so what's x plus 5 minus 5? It's x. Okay, and that's what we would expect to happen. Let's go the other way. So the inverse of f composed with f. Okay, so we start writing down the inverse, x plus 5, but when we see the x, we have to go plug in f. So we get x minus 5, and then it tells us to finish off by adding 5. So x minus 5 plus 5 is x. Okay, so we would say that yes, these are inverses. Okay, and we showed it graphically and we showed it with algebra. Okay, so let's try another one. How about y equals 1 minus x cubed and y equals the cubed root of 1 minus x. Okay, are you surprised to see that there's an x cubed on one side and a cubed root on the other? Okay, hopefully not. Okay, cubed roots and cubes do go together. Okay, so again, if we want to check this graphically, we can just go to Desmos and type those in. Okay, I'm going to leave that bottom one in there. So y equals 1 minus x to the third. Okay, gives us that red one. And then our blue one, if we come down here and do the cubed root, let's see, where's that at? Functions, maybe. Yeah, if we go to that nth root here, we can put 3 and then 1 minus x. Okay, so this one's a little more gnarly, I guess you could say, but it does look like these fold and match up. Okay, we could always check 0, 1 should match up with 1, 0 on the other graph, and it does. Okay, and we probably could find this partner 1.154 negative 5.536. Okay, so that does look like it confirms that these are inverses. Okay, so let's look at this from an algebraic perspective then. So we'll call this f and this the inverse of f. Okay, so using our composition of functions, we're going to put the inverse into f. Okay, so we start writing f down. When we hit an x, we're going to put in our inverse. Okay, so this says to cube that. So we have 1 minus, and we plug this into the cube. Okay, so I didn't color code up above, but okay, so what happens when you cube a cubed root? Okay, well, the inside pops out. Okay, so we have 1 minus whatever was on the inside, which is 1 minus x. Okay, and if we distribute, we get 1 minus 1 plus x, which is just x. Okay, so that worked for us. Hopefully you can see that now. Okay, let's go the other way. Okay, so this one says we start writing down the inverse. Okay, and then when we see x, we have to plug in f. Okay, so just 1 minus x cubed. So we started with our inverse, and when we saw the x, we plugged in our original function. Okay, so on the inside, we go ahead and do 1 minus, okay, what happened there? 1 minus x, whoops, that shouldn't happen, should it? Okay, just give me a second, I lost my train of thought. Okay, so we started writing this one down, 1 minus, and this was 1 minus x. I had my cubed in the wrong place, I apologize. Okay, so we have 1 minus 1 plus x cubed. Okay. And so the ones go out, and we're left with the cubed root of x cubed. Okay, so we have 3 x's, that means we get to pull 1 out, and so we are good. Okay, so algebraically and graphically, these prove that these are inverses of each other. Okay, now let's do one more. Okay, so we saved a little more difficult one for the end, but this is great algebra practice for you. Okay, so the first one is x plus 3 over x minus 2, and the second one is 2x plus 3 over x minus 1. Okay, so these are both those rational functions that we've been dealing with the past few days. Okay, so let's see what we can do with that. So let's go ahead and go over to Desmos and make sure, at least graphically, that they look like they're inverses. Okay, and all the ones that you do today should be, unless I wrote it down wrong or something. Okay, so you're just showing that they are by doing it 2 different ways. Okay. On this, make sure you have the top in parentheses, at least on your calculator. Desmos does a good job of keeping it separated, but if you're doing it on your calculator, make sure that you put your top in parentheses and your bottom in parentheses. So here we go. So if you notice here the blue, if you fold it on this line, it will match with that red right there. And if you folded the red here, it matches with the blue. Same thing down here. Okay. And again, you're not folding blue onto blue, you're folding blue onto red. Okay, so I would agree that this looks like these 2 are inverses. So now let's do the algebra part. Okay. So those who are taking this for college credit, if you looked at some of your review, it's being able to do the complex fractions, and that's what we actually end up with here. Okay, and we did work with that. We will work with some before you take your test, but this will be a great review for you. So f of the inverse of f. Okay, so that says that we start writing down f, and whenever we see an x, we have to put this whole thing in it. Okay, so we have 2x plus 3 plus 3. Okay, whoops. So put 2x plus 3 in for x, okay, over x minus 1. Okay, so that was all for the x, and then we added 3, okay, and then we go to the bottom, and we have to do this for x again. So 2x plus 3 over x minus 1. Okay, and this time we have a minus 2. Okay, so again, here we have x plus 3, and here we have x minus 2. Okay. Now, we need to deal with this. We need to have common denominators. Okay, so up here, looks like the common denominator is x minus 1. So we need this one to have x minus 1. So we've got to multiply it by x minus 1. So we have 2x plus 3 times x minus 1. And that allows us to put it all over x minus 1. Okay. And then down here, your common denominator is x minus 1 as well. And so this negative 2 needs an x minus 1 on top so that it can have an x minus 1 on the bottom and be combined. Okay. And so now we just need to combine. So 2x plus 3 plus 3x minus 3 over x minus 1. Okay. And then over 2x plus 3 minus 2x plus 2 all over x minus 1. Now remember, if these are to be inverses, we've got to get x only out of this. Okay, so we still need to simplify some more. Up top, we end up with 5x over x minus 1 by combining like terms. On the bottom, it looks like we end up with 5 over x minus 1. Okay, so it looks nicer. But now we still have this complex fraction. So do you remember what this bar means? That just means divide. So let's rewrite this. This is 5x over x minus 1 divided by 5 over x minus 1. So how does that help us out? Well, remember when we divide by fractions, we flip. So this is 5x over x minus 1 times x minus 1 over 5. And now we can cross out if something shows up on the top and the bottom. And so the x minus 1's cross out and the 5 crosses out, so we get x. Okay, so far, so good, hopefully. Okay. And I'm sorry if I'm going a little fast for that. Hopefully you can pause your video and complete your notes if needed, or print off the ones that I have on Google Classroom. Okay. Let's do the second part of that. We still need to do the inverse with f. Okay. So similarly, we start with f, the inverse this time. And whenever we see an x, we need to put in x plus 3. So we have 2 times x plus 3 over x minus 2. Okay, sorry. And let's see. So we have 2 times x plus 3 over x minus 2. That's the x part. And we need to add 3. Okay. And then over x, which is our x plus 3 over x minus 2. Okay. And it says we need to subtract 1. Okay. So again, this was our x that we plugged in each time. So it's 2x plus 3. This is x minus 1. We put that into the inverse. Okay. So getting like denominators again, this 3 needs to have an x minus 2. So we multiply by x minus 2. And actually you do it on top and bottom, but since we have it on bottom, it combines with the other one. Okay. And down here, it also needs an x minus 2. So we should end up with this kind of ugly looking thing. Okay. So now let's put it together. and distribute. So we have 2x plus 6 plus 3x minus 6 all over x minus 2. Okay. Then on the bottom we have x plus 3 minus x plus 2 all over x minus 2. So here I just distributed my tops and things. Okay, so let's simplify some more. Top gives us 5x, and the bottom was x minus 2. And then the top of the bottom gives us 5 over x minus 2. So now we can rewrite it as 5x over x minus 2 divided by 5 over x minus 2. And then using our fraction rules for dividing, we flip the second one. So x minus 2 comes up on top over 5. And the x minus 2's cancel out and the 5's cross out, so we are left with just x. Okay? Confirming that these two rational functions are inverses of each other. Okay? So we're going to pause there and would like you to try page 239, 13 through 23 odd. Okay? Doesn't have to be today only, but try some of those until you feel very comfortable graphing them and confirming and using the composition of functions to confirm. Okay, so one more little video and we will be through with this.